Hello again. In this video, we're going to go over the general form of the power rule. Now, in a previous theorem, we did talk about the power rule, which stated that the derivative of x to the n power is equal to n times x raised to the n minus 1 power. But in that previous theorem, it stated that it was only true if n were a positive integer. What the general form of the power rule says is that this is true for any real number n. So it extends this to any real number. Okay. So I just want to look at an example where we use this. So let's say you want to find the derivative of this quotient. So at first, you might think to use the quotient rule. And you can use the quotient rule to find this, but the quotient rule can be kind of tedious to use. And there are times when you can avoid the quotient rule, and in this case, you can avoid the quotient rule. This x to the sixth actually divides both of these terms. That's why this division sign goes all the way across both terms. So there's no reason you can't write it like this. Because x to the sixth does divide both of those terms. Another way to think of this is a common denominator, and when you have a common denominator, you can just write it over one denominator. We're actually just going the other way and writing it as, two denominators. Okay, so now we're going to take the derivative of these two terms that are being subtracted. Okay. Now this is only helpful though if we can get rid of these division signs. This one we can sort of get rid of the division sign because we can simplify this. This is really x to the 10th power times 3. Okay, minus this, and it doesn't look like anything here cancels, and so it seems like we're going to be stuck with this division sign, and we're going to have to end up using the quotient rule anyway. But that's not necessarily the case, because you may remember that when you have x to the 6th in the denominator, that's the same as writing x to the negative 6 in the numerator. So if this is in the denominator and it's written as x to the positive 6, you can always change it to the numerator as long as you change the sign of the exponent. That's true regardless of whether it's on top and bottom. If it's on the top and you want to move it to the bottom, you just have to change the sign of the exponent. Okay, so that's helpful because if you write it like that, you no longer have to worry about the quotient rule to find this derivative. Okay, so you can actually find this derivative by finding the derivative of the first piece and then subtracting the derivative of the second piece. And then since this is a constant, that can come outside the derivative operator, just like this 4 can, since it's also a constant. Okay, and then now you're just left with using the power rule. The derivative of this would be 10x to the 9th, and then multiplied by 3. And then using the general form of the power rule, right, this no longer needs to be a positive integer like it was stated in the previous theorem. It could be, this is true for any real number, including negatives. So we can apply the general power rule to this. And so we get negative 6x, and then subtract 1 from the exponent, so it's negative 7. And of course, that negative 6 is going to be multiplied by this 4. So let me write it like this. Okay, and let's just clean this up. So that's just 30x to the 9th power. And then a minus times a minus would be a plus. So that's plus 24x to the negative 7 power. Now, if you don't like negative exponents, and sometimes we don't, we prefer not to have them, you could always write this as x to the positive 7 power as long as you put it in the denominator. So those are the same. Now notice the 24 remains in the numerator because it's raised to the first power, right? It's not being raised to the negative 7 power. Only the x is being raised to the negative 7 power. And so when you move it to the denominator, only the x goes to the denominator as x to the 7th power. Okay. Okay, so that's the derivative, and we avoided using the quotient rule. Okay, let's look at this last one. Now, in some previous videos, we did talk about the quotient rule and the product rule. And essentially what this problem is about is a combination of both of those rules. Obviously, you're going to need to use the quotient rule here because you have division. And you're not going to be able to cancel and simplify this to get rid of the division. So it looks like we're stuck using the quotient rule. Okay, so let's start there. And then I'll show you sort of what happens and what makes this a little bit different than what we did before. Okay, so the quotient rule says low d high minus high d low over low low. Okay, so low would be this. And then we got to take the derivative of the high. But in order to take the derivative of this high piece, it looks like we're going to have to use the product rule, because this is actually the product of two functions. Okay, so let's find this using the product rule, and then when we're done, that'll be the derivative of the high, and we'll put that here, because it's low times the derivative of the high. Okay, all right, and so the product rule says, and I'm just going to label these. This is the first and this is the second. So the product rule says you take the first and you multiply it by the derivative of the second. But the derivative of e to the x is e to the x. Okay, and then you add that to the second function, which is e to the x, times the derivative of the first function, which is just 4. Okay. Okay, so low derivative of the high, which is this. And I'm going to put this 4 in front of the e to the x, minus the high, which is this, and then times the derivative of the low. Okay, well, the derivative of the low is just 2x. Okay, and then all of that is divided by the low times the low. Okay, and so that's what we get when we apply the quotient rule. Now again, what makes this a little bit different from what we did before is we're actually using two rules. We're using the quotient rule and the product rule. Now anytime you use more than one rule to find a derivative, I think it's important that you first write the overall structure of the derivative. And the overall structure of this derivative comes from the quotient rule. So it's low derivative high minus high derivative low over low low. And then one of those pieces happens to require another rule, right? The product rule. So in order for us to find the derivative of the high, we had to use the product rule. Okay, so let's just kind of clean this up a little bit. And I think we could probably clean this up by distributing, okay? So let's distribute. So it looks like you get, or FOIL, so you get 4x cubed times e to the x, and then 4x squared e to the x, and then 4x e to the x, and then 4 times e to the x. Okay, and then we can clean this up, minus, that's 8x squared times e to the x, And then I'm going to go ahead and write this as x squared plus 1 squared. Those are the same thing. Okay, and then maybe we can simplify this top. These are like terms, this one and this one. Okay, so we actually have 4 minus 8. We have minus 4 of these x squared e to the x terms. Okay, now we still have this one here as well, which doesn't combine with anything else. And then we have this term, which doesn't combine with anything else, and then this term, which doesn't combine with anything else. But these two do combine, okay, to give us this. Okay, and I guess the only other thing I might do with this is factor it. And I've mentioned this before. A lot of times after we find the derivative, we want to factor it because it makes it easier to solve for x if this expression is set equal to a number, which we're going to do in the future. So notice on the top here, you can factor out an e to the x because it appears in every term, but you can also factor out a 4. So I'm going to factor out 4 e to the x. Okay, and that's going to leave us with x squared here. I'm pulling out a 4, so that goes away, and the e to the x, so it looks like I'm just left with negative x squared. Actually, I'm left with x cubed for the first one, sorry. Okay, when you pull 4 e to the x out of here, you're left with x cubed, right? And now 4 e to the x out of here, you're left with x squared. Okay, and then you're left with x here. And you're pulling 4 e to the x out, so that leaves you with a 1. Okay, so that's what we're left with once we factor this 4 e to the x out. Okay, so in the future, we are going to be combining rules for derivatives in one problem. And so you need to get used to this idea that you may be using more than one of the derivative rules in a single problem to find a derivative. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.